Hey class, in today's lesson we're going to talk about sum and difference formulas, which is found in section 5.4 part 1. The objective is to use sum and difference formulas to evaluate trigonometric functions. So, sum and difference formulas, essentially these are the formulas. So if we had to add two angles for sine, it would be sine u cosine v plus cosine u sine v. In other words, it's sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. And you guys can kind of see all the rest of them, so I won't really explain them, but if you see u and v, u just means the first one, v means the second one. And something else I wanted to point out, because I think they kind of look a little funny. These two go together, of course, with sine. Cosine goes together at the bottom, and then, of course, tangent goes together at the very bottom. Okay, so let's look at an example. So in example 1, it says evaluating a trig function. So find the exact value of cosine of 75. Now, typically this is something that you can't do by hand. However, if we use the sum formula, we can. So if you think about your more popular angles, cosine of 75 degrees is the same thing as cosine of 30 degrees plus 45 degrees. Okay? Using the sum formula for cosine, that would be, and again, I'm just going to remind you, that's cosine u cosine v minus sine u sine v. Okay, and that's the cosine, the 30 plus 45. Okay, so for us, u again being the first value, we would have cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. Okay, this is where you want to kind of rely on your knowledge from the unit circle. Cosine of 30 is square root of 3 over 2 times cosine of 45. Remember, 45, sine and cosine are the same. It'd be square root of 2 over 2 minus sine of 30 is 1/2 times sine of 45 is square root of 2 over 2. In the end, that's going to leave us with the square root of 6 over 4 minus the square root of 2 over 4. And just to give them a common denominator, your final answer would be square root of 6 minus the square root of 2 over 4. And that's it. Let's take a look at the next example. And example 2 says find the exact value of sine of pi over 12. Okay. So if we first of all, what we want to do, I wouldn't want to solve this in terms of radians. So I'm actually going to convert it first to degrees. So remember, if you want to take pi over 12 and convert it to degrees, sorry, that's a 12. Ugh, that's terrible. Convert it to degrees, that would be times 180 degrees. 180 degrees over pi radians. So the pi's will cancel. That'll leave us with 180 degrees over 12. If you reduce that, you will get 15 degrees. So essentially we're talking about sine of 15 degrees. Now that's a little bit easier to work with because we, again, knowing that relationship with 30 and 45, this essentially is 45 minus 30 will give you sine of 15 degrees. So again, this is sine of 45 degrees minus 30 degrees. Okay? So we just look for this the sine formula for subtraction. So that would be sine of 45. Actually, let me go back and reference it. So again, when it's subtraction, you would have sine u cosine v minus cosine u and sine v. Okay, so if we continue with that, then cosine u again is the first value, v is the second. You would get sine of 45 cosine of 30 minus cosine of 45 sine of 30. Okay, again, sine and cosine of 45 are the same, so this would give me square root of 2 over 2 times cosine of 30 is the square root of 3 over 2 minus cosine of 45 is the square root of 2 over 2, and sine of 30 is 1/2. In the end, that will give us the square root of 6 over 4 minus the square root of 2 over 4, and again, it's going to look exactly like the last problem, which is the square root of 6 minus the square root of 2 over 4. All right, let's look at our last problem. Here again, it says to find the exact value of the trig function below, given that sine u equals 4/5, where u falls within 0 and pi over 2, and cosine v is negative 12/13, where v falls between pi over 2 and pi. Okay, so this is actually two different problems, so I need to be very clear about that. So let's talk about the first one. Find the exact value of the trig function given that sine u equals 4/5, where u is between 0 and pi over 2. That's one question. And then the other question is find the trig function for cosine, where v is between pi over 2 and pi. Okay. In the first one, if they're saying that sine is positive, and they're also telling you that it's between 0 and pi over 2, that's referring to quadrant 1. So if we draw a triangle in quadrant 1, and I don't even want to use theta, I kind of want to use u. Okay. Sine is opposite over hypotenuse, so the opposite side is 4. The hypotenuse is 5. This is going to be a 3, 4, 5 triangle. So to find the exact value, oh, I just realized I kind of, so I need to find the exact value of, the problem's supposed to say sine u, oh my goodness, sine u, okay, sorry, sine u plus v. Okay, so in this first one, sine u we know is 4/5. That was told to us. And then cosine u would be 3/5. You'll see why we need this in just a moment. Okay, and then with the second one, again, they're telling you that cosine is negative, and they're also telling you that we're talking about pi over 2 to pi. So this one is talking about quadrant 2. So for v, if cosine is negative 12/13, that's adjacent over hypotenuse, so this is 12, this is 13. If I did Pythagorean theorem, I would know that my y value is 5. So again, cosine of this value is negative 12/13. Sine of v is opposite over hypotenuse, that's 5/13. So going back, why did I need this in the first place? Well, to be able to solve for sine u plus v, you needed to actually know the value. So sine of u plus v, again, is sine u cosine v. So sine u cosine v plus cosine u sine v. Okay, sine u is 4/5, and we're going to multiply that times cosine v, which is negative 12/13, plus cosine u is 3/5, times sine v, which is 5/13. What's nice is these will have the same denominator. 5 times 13 is 65, so we'll have negative 48 over 65 for the first one, plus 15 over 65, which will leave us with negative 33 over 65 as a final answer. And again, they gave us 2 trig functions, so 2 triangles that we had to deal with in quadrants 1 and 2 to be able to figure out sine u, cosine v, cosine u, and sine u to get the answer negative 33/65. All right, guys, that's it. If you have any questions, again, please be sure to come see me for tutoring.